Hi guys, a slightly different video today. What I have done is I have read just today the last 20 subject reports. Now the subject reports are essentially after each set of exams, the head examiner, the principal examiner, and his or her team of examiners read all the IAs and the paper 1s and 2s and 3s and give a report back to the teachers and future students about how the exams went, what went well, and what could be improved. Now, what I've done is I've taken out all the key points. I've kind of summarized all of those subject reports because it's a lot to read, and I've put them into this one document. And I'm going to just kind of walk you through all the key points. What I've done in this document here is I have copied the exact quote from the subject report. That is this quote here. Unfortunately, we still came across too many explanations that are a collection of sourced work or proofs that are readily available in textbooks or online. And then I have put, so that when it says key point, this is my words. I have kind of just summarized, obviously the longer ones. I don't want to have to read out everything, but so I've just kind of summarized it here. I have left the longer key or the longer quote from the subject report in the video, so you can obviously pause it and read that to find out exactly what they're saying. But the main thing I want to do is talk about all the different key points, and hopefully this will help us to improve our IAs and to make them look and feel more like what the examiners want. Okay, as always guys, if this is useful, please like and subscribe and check out my website in the link below. Okay, what I've also done guys is I've put the points that are from AAHL, AASL and AISL and AIHL into specific headings. However, pretty much everything is appropriate for all 4 courses because it's essentially the same IA across the 4 courses. The only exception is things, which is why I've put them into these kind of headings. Things like, for example, this one, it's talking about mainly HL students doing really, really difficult maths that they don't need to do. Although I guess that's also appropriate for SL. So it's in these headings because that's somewhat useful, but remember, all of these key points are important for all the IAs. So I've started with topic suitability, and then I move into by criteria. Okay, by criterion. So firstly, if you can Google it, it is not a good IA. I've talked about that before. And actually, one more thing, guys. This video is for when you have some bit of an idea about what the maths IA is. If you haven't watched my IA guide, which is an 8-part playlist on YouTube, definitely watch that first and then come back to this. This is good even if you haven't started your IA, but as well if you've done like a first draft and you want to kind of improve it, this is perfect. Okay, so if you can Google it, it's not a good IA. For example, if you can Google, example I often give, how to prove Pythagoras' theorem, that's not a good idea. It needs to be original. This is appropriate for all 4 courses. Don't use maths that's way beyond the level of the course. You won't be able to, it's not that you won't be able to understand it, but you won't be able to explain it in the 12 to 20 pages, or the short amount of time that you get to do it. So stick to maths that's in your course. Don't do these topics. They've said this many times: birthday paradox, SRR model, Monty Hall problem, golden ratio, Torricelli's trumpet paradox. Just don't do them. No contents page. No contents page or research question. They should not be in your IA. They are for extended essay. Okay, AASL. This again came up in the AASL subject report, but appropriate for everything. Don't do the correlation coefficient by hand. Many students do this. Some of my students have done that in the past. Fine. They say don't do it, so don't do it. In AISL, there's too many IAs. This is this is very specific to AISL. Although again, I've seen it in other topics as well, or in other courses, but there are too many correlation IAs. I marked in the last session both AISL and AAHL, and in AISL, approximately 90% were correlation. Finding the correlation between two variables. There's too many of them. Examiners are now at the point where they don't really like them. I don't recommend correlation IAs at all. Certainly, if you're stuck for an idea, you can do it, and it is possible to do them well, but generally, I recommend avoiding it. You can reach, this is AIHL, and this is an important point, and I get asked this question in my YouTube comments a lot. You can reach the highest levels using maths that is only in the SL course. This is for HL, so this is specific to both HL courses. If you don't have to use, this is a misconception that you have to use maths that's only in the HL part of the course. That's not actually true. You don't have to, but of course it can't be too simple, and you need to show sophistication. So the way they say it in the guide is, it has to be done in a complex way that is beyond what could reasonably be expected of an SL candidate. So whatever that means to you, but you can use just SL course, SL maths. Stick to 12 to 20 pages. Don't go below and don't go above unless you absolutely have to, but generally they say 12 to 20 pages, so just stick with that. Okay, now we're moving to criteria. So criterion A, again, this is in AHL, but appropriate for everything. Keep aim clear and focused. A focused aim. If you just have one thing that you need to do, for example, finding the height of a building, then it's clear. Everyone knows what you're trying to do, and all the maths that you do will then be related to that aim. And that's what this key point says. All sections and maths should link to the aim. That's a big problem, guys, across the world with IAs, is students do maths and it doesn't relate back to the aim that they're trying to do. Once you do that, you show limited understanding of maths, and your IA is not concise. Okay, no need for lots of subheadings. So this is something that's kind of been coming in recently with IAs around the world. Students putting in lots of different smaller subheadings. We don't need them. They're not needed. Pages should be numbered. Number your pages. AASL, clear and precise aim, same thing. So some of these guys are repeated. And actually, when I say I read 20 subject reports, which I did, so there are so many similar comments in all the different subject reports. They're very, very, very similar, and I'd recommend reading some of them in their entirety. But again, the idea of this video is to save you the pain of having to do that. Okay, next key point. You will be marked down if sections or maths irrelevant to aim are included. Same thing. Key point. Introduce tables, graphs, and diagrams with clear writing. So don't just have a graph appear and not say anything, or even say something about it underneath. You should say something about the graph before the graph. So you introduce the graph. This graph shows, the graph below shows this, or graph 1.1 shows this. Same thing, 12 to 20 pages. AIHL, right? No need for, again, a lot of my students put these sections in. I don't know why, because I never tell them to, but a lot of them put in evaluation at the end, limitations, and extensions. They're not needed. Just a short conclusion, less than a page at the end. Okay, criterion B. The key point here is everyone should be able to get 4 out of 4 in this criterion. They say this all the time in the subject reports. This is the one that the IB considers to be the easiest criterion. I'm not sure if I'd agree, but yeah, everyone should be able to get 4 out of 4. Again, watch my videos on each criterion to kind of give a better overview of what's required. Label the axes and define variables correctly. So as soon as you bring in a variable like x, you got to say what it is. Tables on one page, equations on one line. Don't have tables split over 2 pages. Okay, this is important. Define key terms and variables when they first appear, not at the beginning of the IA. So some students say, in the following IA, A means this, B means this, C means this, D means this, etc. But it's better to write the IA so that it flows nicely, and as soon as you come across a variable that you call t, you then say t represents, or t means the time in seconds, or time in seconds, whatever. AASL. Yeah, degree of accuracy. This is important. Why are you rounding to 2 decimal places? In context, I give a nice example about, I think I do high jumping. I say do not put, the high jump was 1.34567889 meters. Round to 2 decimal places because that's what high jumps are measured in. Always label axis, even if zooming in on the graph. So sometimes students zoom in on a graph and they say, look, here's the error. Here's a view of the error, but even then you should label the axis. Reflect throughout, not just at the end. Very, very important key point. That's pretty much written in every single subject report. If collecting a sample, think about and discuss the sampling method. Sampling is now part of the course, so you can talk about different sampling methods. AISL. Again, appropriate for all the courses. Use the approximately equal sign when needed, not the equal sign. If you're rounding, it's the approximately equal sign, which is that one there. Calculator, no calculator screenshots, definitely not. And no calculator notation like this. I've seen this in IAs before, guys. I really don't like it. People say, I then pressed normal CDF 20. That means nothing to someone who isn't familiar with that particular calculator. So definitely don't use that. And always italicize variables and parameters, including in the text. Another common mistake is students, when they italicize the equations, but then when they're writing about the equations, they don't italicize the variables. Okay, no long tables. The first few lines can be in the IA, and then you put the rest of it in the appendices. Okay, criterion C. It is not, and you see a lot of things repeated here, guys. It is not about effort. It is about the engagement in the mathematics. You need to come up with your own ideas and be creative. Again, not about how much you are interested in the topic of, say, horse riding. So it's like, just because you love horse riding and your IA is about horse riding doesn't mean that's good personal engagement. The personal engagement is about how you engage in the mathematics related to the horse riding and your aim. It is about engaging the maths to develop the exploration. Explain the purpose of the maths used to help achieve the aim. So it's about the maths, and you'll see the word maths, guys, written in all of these key points. Show creativity and independence. Refining a model is a good example of personal engagement, right? So a lot of my students do modeling IAs, and you create a model, and then you can actually refine the model by saying, right, this model's fine, but it could be better if I did this. And this relates nicely to reflection as well, which you'll see soon. So you reflect, say it could be better if I did it this way, and then you create a new model, and then you can even go again and say, right, this is better because of this, this, and this, but what if I tried this other thing? Maybe this would be even a better model, and then you create a new model. That's a good way of showing personal engagement. Carrying out an experiment or creating a questionnaire shows personal engagement. You don't have to do that, but certainly it's good if you do it. Again, collecting primary data, it's not required, but can help with personal engagement. Correlation IAs don't do well in this criterion. The very few correlation IAs get more than 1 out of 3. Again, it is about the engagement in the maths. If you can Google it, it won't score well, like at the beginning. You need to show creativity and independent thinking in reacting to problems as they arise. So a bit like I said there, you're writing your IA, you're exploring, you're exploring using your aim, and then you come across a problem and you react to the problem. And the reaction is, okay, I need to solve this problem. What can I do? Why don't I try this? Or I could try this. Let's try both things and let's see which works out the best. So that's kind of, again, it's like personal engagement. It's definitely the hardest one to to define exactly what it is, but this is what the IB are coming back with. Better to collect your own data than to find it on the internet. Again, that's what they've said here. It's not, you don't have to always collect your own data, so don't feel you have to, but it's just saying that does show personal engagement. Okay, criterion D is reflection. Pause and reflect throughout your IA. Are your analysis, strategies, and results appropriate? You have to, every time you do something and get a result, you have to stop, pause, and reflect and think about it. How appropriate is this result? How appropriate was my method? Merely noting limitations or extensions is not enough. I think you get 1 out of 3 if you just note limitations and extensions, but you have to go further. If creating a model, test it. Think about what does it make sense, and comment. Again, same kind of thing. Comment on your model. The key point here is not many students are getting 3 out of 3. Think how your method can be improved. So same kind of idea. Level of accuracy is important in criterion D because you are reflecting on the level of accuracy. So that kind of fits into both B and D. And think about how confident you are in a result from your method. So you get a result and you think, right, this is a result, but don't just say this is, like, for example, you're getting the area. One video I've done is the area of the Jumeirah Beach Hotel. You get the area. Don't just say this is the area of the hotel. You have to then think, well, how accurate is this? How good was my method? How confident am I that my result is between a certain range? Again, same thing. Reflect throughout. This comes up in every single subject report. If there is uncertainty, talk about your confidence in a solution. Same thing. How confident are you in your result? Consider alternative approaches. Interrogate your model and test for viability. So that means test, will your model work? Does it work over the long term? No bullet point reflection or within a table. So sometimes people say, here is my reflection, and they give a table of all the different points. They don't want that. So don't do it. Simply describing results will only get 1 out of 3. Reflection should drive the exploration forward. Now, they talk about this a lot, about driving the exploration forward. And what that means is, a bit like what I said before, you get a result, you do a method, you reflect on it, you discuss, you find the problems, and then that's what drives it forward, as in that's what tells you what to do in the next step, right? I've come across a problem, I need to fix this problem, and then you fix it. And then you keep going. If using technology to create a model, this is important, guys. If using technology to create a model, make sure to describe the shape of the data, then give mathematical reasons for choosing a function. What I see, and a lot of my YouTube videos do this, I create a model using GeoGebra. But what a lot of students do in their IA is they find the data, put the data into a scatter graph, and then they just use the fit function on GeoGebra, and it just a beautiful quadratic appears, and they just say, here's my data, here's the quadratic, and that's it, without actually talking about why you would choose a quadratic in that given situation. So first, introduce the data, reflect on the data, look at the data, decide what does the data look like, and what function might make a good fit, why would it make a good fit, and then you fit the function using GeoGebra. Consider the impact of accuracy and rounding can have on results. So again, similar kind of thing, guys. Talk about how accurate your results are. Reflection should create questions which drive the exploration forward. Same thing that I just kind of mentioned there. AIHL, if possible, put bounds on the accuracy. So same thing. Imagine you get the area of the Jumeirah Beach Hotel, and let's say, for argument's sake, it's 1,000 meters squared. That's your result. But how confident are you? But imagine you could say, well, it's definitely less than, and then you find a bound somehow. It's definitely less than 1,200, and it's definitely more than 800 or something like that. If if possible, quantify errors. So yeah, if you've got errors, quantify them, which means give them a value. How big is the error? Support your reflection with evidence. Yeah, if you're going to say something, have some evidence to back it up. Okay, criterion E, which is use of mathematics. AHL, same point I've mentioned. It doesn't have to be, you can read this guys if you don't believe me, it doesn't have to be in the additional HL topics, but it can't be too simple. Key point, don't go beyond the level of the course. I've mentioned this already. Need to be understood by a peer without any access to outside sources. I always do this, guys. Once my students have done their first draft, they read each other's IAs, and a student in your class should be able to follow what you're doing in your IA. If you're not, then it's your problem, it's not their problem. Because if you have done something complicated, fine, but you need to be able to explain it in a way that they can understand. And certainly your teacher should be able to understand it. Because sometimes I get IAs and I just can't understand it. And I have to go back to the student and say, I don't understand, explain this to me. And then they actually can explain it to me, and it does make sense, and it is mathematically correct. But I can still say to them, fine, I get it now, but you need to explain that in the paper so that I could read it and understand it as I'm reading it. Very difficult to get a 6 out of 6 in HL. That's true. It's much easier, obviously, to get it in standard level. If you read the criteria, you'll see exactly why that is the case. It's the one criterion where there's a difference between SL and HL. It's the criterion E. Don't calculate the correlation coefficient by hand. I've mentioned that before, but it came up in criterion E as well. I've also mentioned this. Consider the behavior of the data before fitting a model using technology. A higher degree polynomial will always have a better R-squared value. It doesn't mean it is a better model. I've talked about that in various videos, but if you're trying to fit a function onto data points, if you fit a cubic, it will have a better R-squared value than a quadratic, and a polynomial of degree 4 will have a higher R-squared value than a polynomial of degree 3. It doesn't necessarily mean it's a better model, so that's why you have to go and talk about the shape. So just be very careful with the R-squared value, make sure you understand what it is. Maths irrelevant to the aim shows limited understanding. So be very, very careful, guys, because as soon as you put in maths that's irrelevant to the aim, you're now stuck at 3 out of 6 because you're showing limited understanding. So do not do that. If it's in the syllabus, no need to show how the formula is obtained. Example, the R value. Again, they mentioned the correlation and Pearson's correlation coefficient a lot, but you don't have to show how this is calculated. You can just use your GDC. It just says here, candidates scored low in E. This is particular for AISL because they didn't show understanding through reflection. So it's not just like, fine, if you show some calculations and you understand it, you haven't actually shown that you understand it if you haven't written about it correctly. Final point. The R-squared value is appropriate for interpolation, but not for extrapolation. So just be careful here. That means that, and actually gives an example for fitting a curve to a vase, which I actually have a video for. But if you're going to mention R-squared, it's fine for talking about how well the curve fits within the range of data that you were given. But if you're going to start using it for predictions, it says here, extrapolation or predictions, it's perhaps not an appropriate measure of how well the function fits. Okay, that's it, guys. Sorry, that's quite a long video, but obviously you can go through it at your own pace. Go over your IA again with this advice, and perhaps you might want to do things like, well, simple things like remove the table of contents and all the kind of section headings, small things like that. Okay, hope that was useful, guys. And I'll see you in the next video.